everyone, so in this video I'm going to talk about the insertion sort algorithm. In the previous videos I talked about the bubble sort algorithm, selection sort algorithms. Okay, so in this video I'm going to be talking about insertion sort. So of course, as like the other videos, I will explain it, and then I will code it, and then I will say the time complexity of it, space complexity of it, how it's working. Okay, I'll say all the things in this video. And in the my upcoming shorting algorithms courses, I will be doing cyclic short, quick short, merge short, and also after this course, this playlist will be for some time. It will be paused because I'll do like the data structures part after that, and after a couple of months, then I will come back again, and I will start with the advanced sorting algorithms, which is basically the radix sort, shell sort, basically topological sort, counting sort, etc. Okay, I'll explain those also. So let's get started with the insertion sort, right? So how insertion work? Let's uh, see it first. So insertion sort. So insertion sort. So what happens in the insertion sort? Suppose we have a list of elements. Suppose we have a list of elements. Suppose it is 3, 4, like 5, 2, and 1. It is like any random list of elements. Okay. Now, what happens in the insertion sort? Suppose we have shorted, a shorted list. So in case of the insertion, this is already shorted, right? So if we have to if we have to insert it's not suppose we have a 4 here, suppose is it that would be better. We have 4 here, suppose a 4. Now in this case, if you have to add, like if you have to insert 3 here in this shorted list, and we want that after the inserting the 3 in this shorted list, the new list will also it also should be shorted. Okay, so what do we have to do? We have to insert it in the middle of 2 and 4, right? So what it will become? It will become 1, 2, 3, and 4, because we have to insert it in the in between 2 and 4, so that the output would also be shorted. It is also shorted, right? That's what's the concept of the insertion sort. What happens in the insertion sort? We take first of all the first the first element. So if it is one element that is already shorted, right, the first element, and then we are inserting the next element here, next element, if we take this is the suppose this is another list with only one element. So if we have to insert 4 in this list, so and we want that the outcome after inserting 4 in this list, we want the outcome will also be shorted. So where we should like where should be where should have to insert it? We have to insert it after 3, like 3 and 4. So we have to insert it like this: 3, 4, 5, 2, and 1. So this is the, now this is the new list. 3 and 4 is the new list. Now you have to if we have to insert, like we insert it here, now you have to insert it here, like this is already sorted, 3 and 4 is sorted. You have to insert 5 in this list, so we have to insert it 3, 4, and 5, right? So that is the thing. We have to insert it at the last 3, basically after 5. So what it will become? It will become 3, 4, 3, 4, 5, 2, and 1. So this is the new sorted list. Now we have to insert this one in this list. So where it will go? It will go in the and the fast, after, like, before 3. So what it will become? It will become 2, 3, 4, and 5, right? And here is 1. This is the new sorted list. Now we have to insert it in this list. So what it will become? It will become 1, 2, 3, 4, and 5. So now this whole list is sorted, and we sorted it by the method of insertion sort. This is the basic thing of the insertion sort. Now if we talk about the algorithm, how it works, we'll basically take I and j variable, as we always do in the bubble sort, also in the selection sort also. So we'll take it, let's see how to implement that, like how it works in the code. So code, if it's over the code explanation. Okay, code explanation. Okay, code explanation. So what I'll do, suppose we have the list, whatever the list, suppose we take in this list 3 4 5 2 1, list 3 4 5 2 and 1. Suppose we have this list, right? So we have a I equal to 0. Suppose first of all we have a I equal to 0, and we're taking j is equal to I, right? So so in the first case, j is basically j is also equal to 0 because I is equal to 0, right? So I equal to, the first case I equal to 0, j is also equal to 0. Okay, so this is the, so what we do, this is the first case where I equal to 0, j equal to 0. That means it is in the, yeah, I is also pointing to here, j is also pointing to here. So or j is also pointing to here. Yeah. So in this case, we are here and j is here. So it is here only, right? So there is no condition. What is the condition? We'll check. We'll check like this. Okay, let's first explain, because it is in the same. It pointing to the same index. So let's increment I. Because there is no meaning. Like increment I, which is basically, let's increment I to 1. So now j is also should be, j is also should be 1. Okay, j should be 1. So so what happens? So now if we remove it, now we are, now we're here, and j is here. J is basically, j is here, and the 0th index. So what we'll do, we'll take the fifth element, like okay, we have done, we have skipped its step here. What is skipped generally? Here will be it'll basically j, right? So it is 4. This is the element, this is the first element, this is the first list, first shorted list, you can say, because it is one element is already shorted, right? We don't have to short it, or we don't have to say like to ask a question, is it shorted or not, because it has contains one element, so one element is always shorted. So this is a shorted list. So we have to insert the fourth, like this element, fourth element here. Okay, fourth element here. So I and j, fourth element I have to insert here. So this one I have to insert here. So while I'm inserting it, while check, it will be 3 and 3 4. It will compare, like the condition will be, if the basically the right hand side element is less than the left hand side element, then will be a swap. Okay, so is it true if right hand side element is less than the left hand side element? Like if 4 is less than 3, it's not true, right? It is not true. That's why it is stay as it is, and this is the new list, new shorted list, and 5 2 1 back. Now this one I would also go here, so it will check with the 4. Like if it is j, it will check with the j minus 1. If it is j, it will check with the j minus 1. Okay, if it is j, it will check with the j minus 1. That's right. Okay, so we will check with the j minus 1. Yeah, so what will check, if 5 is, what will check, if the right hand side, if 5 is less than 4, is it true? No, it is not true, right? So it will stay as it is, like 3 4 and 5 break out of here. So this is the new shorted list. Now 2 and 1, Now 2 will go here and it will check if 5 is less than 2. Okay, so the left, this is the right hand side, right? Okay, this is right hand side. So okay, that means it will be 2 is less than 5. Yeah, this is true. So it will swap. uh, this position will be swapped. This position will be swapped. Okay, uh, and it will become 3, 4, 2, and 5. Till now it is not short. Till now it is not shorted. So what it will do? It will check with now again. Suppose here it is j and j minus 1. Okay, now it is j and it is j minus 1. So it will check again. So if 2 is less than 4, yep, it is true. So it will again swap. It will become 3, 2, 4, 5, and 1. Till now it's not shorted, so it will check between these two. Now if 2 is uh, less than 3, yep, this condition is true. So this 2 will be like swapped and it will become 2, 3, 4, 5. Now it is shorted, right? And now 1 will be inserted. When you say 1, it will go to the same step and it will compare with every thread and it will be swapped with every element here and it will go to the first. So it will be 1, 2, 3, 4, and 5. That's how it is sorted. So we have to take ith index to iterate, basically to increment this thing, to increment the list. First of all this one, then this one, then this one, then this one, right? So we have to increment it. That's why we need 5 steps, right? 1, 2, 3, 4, and 5. So we need 5 steps. So it will go to I equal to 0. Basically it will take n steps. If we have n elements, we will take n steps for the ith. And j, first of all it will be equal to I, and it will be equal to I, and it will compare with this j minus 1th element. Okay, first of all it's I and it will compare with element and its value is bit decreased because what we're doing, we are comparing first with this. Like here in this case we're comparing first with this, then this, then this. Like it's decreasing, j value is decreasing, sub element is decreasing. That's why generally uh, generally I value is increasing and j value is decreasing. Okay, so that's the whole explanation basically of the insertion sort. It is a simple algorithm and it's not a very complex one. And you'll get more clarity once you see the code of it. Maybe you could not figure out what happens here, like how the code explanation is working. I'm sure that you understand how it is working, but maybe you didn't understand how the code explanation is working here. I'll do it. I'll do it in a second. But before that, let's jump into the time complexity and space complexity of this algorithm. So what is the time complexity and space complexity of this algorithm? So, the time complexity. So in terms of time complexity, basically normal elements, we have like suppose in this case we have 5, and norm of outer steps, in this case it is also 5. Actually it's 5 because here is 1, 2, 3, 4. This one is like older one. So this one is actually, this one is for 1. One is one step, one outer step. That's why it is 1, 2, 3, 4, and this one is 5. Okay, so this it has basically has 5 outer steps. Okay, and norm of inner steps. Use of the norm of inner steps. Norm of inner steps. So what is the norm of inner steps? Actually it depends, but in the worst case what it will become, it will be 1. In the worst case it will be 1. It will have a 2, 3, 4, and up to nth element, not nth, it will be n minus 1 element, because last one will be here and will be traverse to the fourth, basically 4 places, so it will be n minus 1. So The inner steps is 1 plus 2 plus 3 up to n minus 1. Okay, so we know the Sn formula is the first term plus last term divided by 2, right? So the first term plus the last term divided by 2, and it gives you n upon 2. Okay, and in this case, since suppose we have n number of elements, and so in this case also it will be n, right? So this is the time, this is the some say observations we can say. And now we'll cut with the time velocity. So the total number of steps, total, so we can say total steps. So the total steps is n, the norm of the outer steps into the norm of multiplied by the norm of the inner steps, right? And multiplied by the norm of the inner steps. Inner steps is n upon 2. So it will be n square upon 2. Since we we have to remove the constants in the time complexity, that means time complexity will be n square upon basically n square, because you have to remove the constants. You don't have to consider the constants. And if this is space complexity, is easy. It is easy. It is same as the bubble sort and the selection sort. It will be go of 1, because we are not using any auxiliary spaces or any extra spaces, or any say any extra data structure, any extra array. In this case, to sort the list, it is straightforward. It doesn't need anything extra. That's why it is constant. It is big of 1, right? I hope you understand the whole explanation of the insertion sort. Now let's jump into the code. Let's see basically what is the implementation of the insertion sort. Let's do it. Let's code it. Let's go to the Replit. Here we are. So let's open the CodaGo folder. Have you already done section sort and bubble sort? If you want to do it, if you want to check it out, you can do it. We're creating a new file, Java, and name is insertion sort. Name is insertion sort. Create the REPL. It's taking time. Yep. Now we're in the REPL. Let's implement the code. So the list of elements here, like defining the list of elements. List of elements. Be int. There are the array of elements in the end. That's how we define array in Java. 5, 4, and like 1. There's any random like elements in array. So the insertion sort code. So with the outer loop, it will go from I equal to 0 to the end. Like it will iterate n steps for the n steps, right? Because we see here, we have seen here the norm of outer steps is basically n, right? So it will be int I equal to 0, I is less than n, I plus plus. I don't know why it is screen curly braces like this. Should not actually. 4 and j equal to I, j is greater than n equal to 0 and j minus minus. Because j is decreasing, right? I already said it, j is decreasing. So now, so what I have to do, like here is j, so decreasing again, it is decreasing. J is here, then it's here, then it'll be here, right? Here, like here, then it'll be here, Okay, that's how it's decreasing actually. So it's not equal to 0 actually, equal to 1, because at the last when j is 1, then we also have to check j minus 1, right? We also have to check here j minus 1, right? So if it is j value is tends to 0, then j minus will be minus 1, and uh, there is a no basically negative number can't be an index always starts from 0, right? So that would be not valid in this case, in that case. So j would be go till 1 only. Okay, so now we'll give a condition here. What condition will give? Left is less than, basically right is less than left. If this happens, then we swap the elements. So what is right here? What is right here? What is right here? So right means uh, basically this set of elements, right? What is this set of elements? J. That means right is ARR of J, and left is this set of elements. That means left is ARR of J minus 1, right? That means we have to write it is ARR of J, like ARR of J is if it's less than ARR of J minus 1, then we have to swap it. How to swap? I already told it in that like bubble sort algorithm, and also I have used in the selection sort algorithm, right? So in tam ARR of J, ARR of J equal to ARR of J minus 1, and ARR of J minus 1 is equal to, yeah, that's how we swap it. This is the code of the insertion sort. Is likely it's very easy, and you can also give in a condition. It will also work, but it can also give a condition. If it doesn't work, like then else break. That means the rest of the parts is already shorted. What I mean here, like let's go to the last page. What I mean here, so if I have a list like 2 and 2 3, and we have a 5, and we have to insert 4 in this list, right? 4 in this list. So what it will do, it will check with this, right? It will check with this if like if right hand side, if right hand side is less than left hand side. So what is right hand side? This one, 4 is less than 5, it is true. That means swipe with 5, it will swipe with 5, right? It will become 2 3 4 and 5. But in the other cases you don't have to compare, because in this check only, it will say, in this check only it will say okay, 3 is basically 4, not 3, 4 is 4 is less than 3. This condition gets false. That means we have to break from the loop, and it is shorted. It is now shorted only. That's what I did. If this condition gets false, we have to break from the loop, because we don't have to check for the other like elements, because we know this is already shorted. This is swapped. That means this gets here and this gets here. That means if the other conditions gets false, then that means it's already shorted. Then you don't have to bother for the other like the rest of the sub list, because we know it is shorted, right? So that's why we are breaking from it. So at the last, let's print it. Printing the elements. So 4 and I equal 0, is less than dot length I plus plus system dot out dot print and ARR of I. Yeah. So let's run it. Okay, it gives an error. Okay, here we n, it's not n, it's the length, so it'll be arr dot length actually. Yeah, silly mistakes are always gonna happen. So 1 2 3 4 5, yeah, it's shorted, right? So if we give it anything here like 9 7 10 and we run it, yeah, it gives a shorted list, right? It gives a shorted list. So let's try this time complexity here. So time complexity for the reference, time complexity is big of n square, and space complexity is big of 1. It is a constant space complexity, right? This is the whole video of the insertion sort algorithm. Hope you like it. If you like it, then like the video, share it, and like post it on Twitter, LinkedIn. If you're learning in public, then take a screenshot and share it in Twitter and LinkedIn. That'll be a great way to contribute to the society, because the peoples will see this video and they will get to know about something. That'd be great. See you in the next video. For now, bye bye.